Welcome to the world of thermal imaging, also referred to as thermographics. We are the MCAT team and allow us the opportunity to introduce you to the use of thermographics in precision agriculture. Farmers are always obsessing about the weather, and it makes sense why. No rain equals no grain. To compensate for the lack of untimely rain, producers use irrigation. However, this practice has high expense and needs sustainable solutions with the rapidly depleting aquifers. It is vital to make every drop count. Today we know there is an incredible amount of variability across crop production. Changes in soil texture, topography, wind, and the time of day will affect how water infiltrates and is held in the soil profile. This variability needs to be taken into account in our irrigation scheduling. Our team is developing state-of-the-art thermal imaging platforms to correlate thermal imagery of the crop canopy to a variable rate irrigation schedule that is economically feasible for your average producer. A typical thermal camera can show temperature variability within a frame. Unfortunately, out of the box, the thermal camera cannot tell us the actual temperature of the object. However, through our calibration testing, we were able to derive a near-perfect correlation between temperature and the digital pixel intensity. Our team did this by placing the thermal camera within an isolated chamber to correlate the thermal image with the actual raw temperature data. Our preliminary testing proved very positive as we determined the range of temperatures within the camera under different camera settings. By evaluating the camera settings, the camera could be set for the range of temperatures expected in the field or laboratory. These tests proved very positive, but further testing was needed to take into account variables like humidity and air temperature that could skew this relationship. By controlling the air temperature, we could change the temperature of the camera to observe the extent temperature influences the measurement accuracy, as shown in the graph on the right, where the dark purple is the measured temperature and the light purple is the actual temperature of the surface. However, what we see in the lab and what actually takes place in the field can be entirely different. So the true test comes when we are able to step out of the lab and into the field. We strapped our thermal camera to an unmanned area vehicle and thermal sensing took flight. With the drone sensing platform, our team is able to view the thermal imagery of crops as they actually exist under field conditions. As we move forward, our processes and calibration capabilities are improving to fine-tune our practice. When our team is finished, even the slightest bit of water stress can be detected and managed appropriately. Thermal imagery will remove the guesswork from irrigation scheduling to reduce cost and sustain water resources for generations to come.